Now it is time to start the first keynote presentation of the Asia Pacific Domain Name System Forum, APAC DNS Forum. It features a multitude of topics discussing the role of the DNS from various perspectives, aiming to serve as a platform for participants to network, exchange ideas, and explore collaboration opportunities. In addition to the technical topics such as cybersecurity and emerging technologies, the section will also cover industry trends and business opportunities such as spurring online business growth and digital brand protection, to broader topics like the potential impacts of regulatory, policy, and technological developments on the DNS industry. Our first keynote speaker is Mr. John Crain. Mr. John Crain is the Senior Vice President and Chief Technology Officer of ICANN. In his capacity, he is responsible for leading ICANN organization's efforts to improve knowledge about the identifiers and helps coordinate and disseminate this information to the Internet community. He is also responsible for oversight of the Internet Assigned Numbers Authority functions. He is also a member of the org executive team. John works with staff and the community to enable and enhance capabilities that improve the overall security, stability, and resiliency of the Internet identifier systems and associated infrastructures. Without further ado, please welcome Mr. John Crain.
Well, good morning, everybody. Thank you for inviting me to Hong Kong. I'll start by thanking Mr. Tony Wang from the Office of the Government Chief Information Officer, Mr. Simon Chan from Hong Kong Internet Registration Corporation Limited, and Professor Li Jing, who's the Professor of Electronic Engineering Department at Tsinghua University. So I've been asked to give a keynote, so I will do that. Now, I'm an engineer by trade, so that means I'm going to have white slides with lots of very small font letters. And my colleagues said I couldn't do that, which I thought was very mean. So instead, I'm going to go with colorful backgrounds and big text. So they've given me a bunch of keywords, and I will try and talk to them. So the first one that we have is, of course, what is the DNS, the domain name system? Now, if you're at this conference, I hope you have at least the basic understanding of what it is. If anybody is not here for a domain name system conference, you're in the wrong room. The other conferences are down the road. So the domain name system, as we've heard from previous speakers, and we will hear more about later in the day, is one of the key elements that makes the internet work. Simply put, it's the anchor that we use to find our way on the internet. Now, I see some of my colleagues from the regional internet registries and the IP addressing people here, and they will remind you that it's actually IP addresses that are used to make data move from one place to another. But domain names are the things that we print on business cards. It's the things that we use that are an anchor point that doesn't have to change even when we move services from one ISP to another. So we use the domain name system for pretty much everything we do on the internet. Domain names and the name resolution, and then IP addresses and routing are sort of the thing that makes the internet work. It's extremely boring if you're not in the industry. Most end users do not care and probably should not care about the inner workings of the internet. But without the DNS, we don't get to travel around the internet and find our way to services. So what does ICANN do? ICANN is the Internet Corporation for Assigned Names and Numbers. We have two basic things that we do. One is we operate something called the IANA functions. IANA is the Internet Assigned Numbers Authority. You will notice a pattern. We like acronyms or initializations. We like to not tell people the real words and just spell things out in letters. So I am ICANN's CTO. I have a department that works underneath me called IROS, IROS, Identifier Research Operations and Security, which has the OCTO, which is the Office of the CTO, and the IANA are the two parts of what I do at ICANN. So the IANA is where all the names at the top level and the numbers, IP version 4, IP version 6, autonomous system numbers, enterprise identification numbers, and thousands of other parameter types that make the internet work and the end users have no idea exist, are registered. The IANA is the central point, the operational point where the internet identifier systems begin. The other thing that ICANN does is specifically for domain names is we set global policy. So when there is a decision about adding new top-level domains to the ecosystem, that happens in the ICANN forum. It is a multi-stakeholder forum. That is a fancy word for meaning anybody can come to the meetings and have input into the policies. It's made up, if you come to an ICANN meeting, of everything from engineers to government ministers, civil society, researchers. There are so many, and of course industry people. And I see many faces in here that occasionally come to ICANN meetings, so many of you are familiar. But we set those policies as a multi-stakeholder community about how the DNS works, specifically for what we call generic top-level domains. Those are the things that used to be only 6 or 7 of them, with things like .com, etc. But we also hold the IANA side, the operational side, for the country codes. So the country codes, like .hk, also come to us when they want to make technical changes to their infrastructure in the DNS root zone. So in short, that's sort of what ICANN does. We register databases of identifiers, extremely exciting stuff, and then we have policy-making forums that happen around the globe at least 3 times a year, and make the policies. And I think you'll hear more as we talk throughout these couple of days. So a lot of this conference is going to be about what's going to happen in the future, but I want to take us back a little bit. So ICANN this year will have existed in November for 25 years. I have been at ICANN on and off for about 25 years. So I started when I was 4. Yeah, that's a lie. But I've been at ICANN for about most of those 25 years, and I've been involved in the internet industry for a little bit longer than that. But you know, it sounds like a long time, but in the history of technology, 25 years is nothing. And the domain name system, the first RFCs, request for comments documents that document the protocols, go back 40 years. Also not that long ago. 1983 was an important year for technology. Who here remembers technology in 1983? I don't, because I was only 4 25 years ago, but I may remember some of it. So 40 years is a long time in the internet. So what happened in those 40 years? Well, let's go back 40 years. 1983, the Apple Lisa was a very important milestone in computing. Not because of the computer, but because it had something called a graphical user interface and a mouse, and you could move arrows around your screen and click on things. It was a game changer. And that thing on the bottom there is a Motorola Dynatec 8000X. I had one of those, so maybe I am older than I'm letting on. And they were awesome. This is a telephone without a wire. It was magic. You could take a telephone with you in your car or in your briefcase, not in your pocket. You could not put it in your pocket. It was a little bit too big. So that was 40 years ago. And if you look to today, we have these. Right? Everybody is carrying something like this. It has a graphical user interface. Everybody takes it for granted. It has thousands of times more processing power than the Apple Lisa had. This one happens to be made by the same company. It doesn't just do voice. Right? In 1983, we were all really impressed by the fact that you could actually have a voice call and be mobile. You could be in your car or your office or go to a coffee shop and have a phone call. We've come a long way in 40 years. I mean, a really long way. This is like science fiction compared to what we were looking at back in the early 80s. Other things that happened in 1983, a network called the ARPANET moved to a protocol called TCP/IP, the Internet Protocol, also in 1983. It was a good year for technology. There was a lot of change. So what's next? I mean, if we've come this far, where are we going? Well, I'd be lying if I said I knew. We didn't predict we would be where we are today in 1983. Star Trek did. Star Trek did a pretty good job with the technology, but people like me didn't really predict where we would be today. So one of the issues that we're faced with, it's not really a DNS issue at all, although DNS has a role to play. We have about 5 billion users, billion with a B, on the internet today. That might seem like a lot of users, but there are about 8 billion people on the globe. And those sort of between 14 and 65, there's about 6 billion people on the planet. Now, my daughter, who is under 14, would disagree with this because she thinks you start using the internet when you're like 2, which is probably true for kids these days. But that means we're missing at least 1 billion people. There's at least 1 billion people who probably should have access to the ecosystem that we all work in and enjoy, and the information that we all have access to, and they don't. So we're not done. Not by a long way. Many of those people are either in the global south or here in Asia, Latin America. They are not in the traditional place where much of the internet was built. They're not in the United States or North America, and they're not in Europe. Right? So most of these people are actually in different places. So 55% of the website content this year, found some statistics on the internet. You can find all kinds of information on the internet. About 55% of the content is written in the English language. But only 26% of the users are actually native English speakers. So that might be a detriment to people getting access to the internet. What do we do about that? How do we change the ecosystem to use languages and scripts that people who don't speak English natively or who struggle with English can use the internet. Now, content has been pretty much solved. You can put content on websites, etc., in pretty much any script. 45% of it is not in the English language. It may be in ASCII script still, but there's also content in other scripts and languages of Chinese, Thai, many of the African and Indian languages. So the content exists. You can't actually, in this day and age, do everything on the internet using those identifiers. Remember I talked about ICANN being the place where we do things about identifiers. So we're not really a content shop. We're about the roads, the ways you get to places. We're about those identifier systems. Now today you can register a name in a different script. We've figured that out. It works. Inside the DNS, it is still ASCII, but we have ways of transliterating from an ASCII domain name to a name in other scripts that can be displayed in your browser, and you can type in your browser. So that is working, but we don't have many of them. The majority of domain names today are still in ASCII using what looks like the English language. That probably needs to change as we go ahead. We probably need more identifiers in other scripts so that people can use their native language to find their way around the internet. Now, if you're in this room, you're probably sitting here thinking, well, I've done fine with a QWERTY keyboard and English. But you're not the audience for this, right? We're not the people who are having difficulty connecting to the internet. We are not part of that 1 or maybe 2 billion people who are not able to access. So this is one of the things that's on ICANN's mind, is how do we internationalize the identifier systems? And the ones that people use, the ones that are human readable, are not IP version 6 addresses. Those can't even be read by engineers anymore. They're domain names. So can we internationalize the domain name system? And this has been going on for quite some time. The answer to that is yes. But it's no good if we can't use those domain names. So if you've heard of the term universal acceptance, it's a term we hear in the ICANN world quite a bit. This is about making sure that names that are different to what everybody's used to, so it's not just different scripts, it's actually things like longer domain names. There was a time even in the early 2000s, when if your top-level domain was more than 3 characters, it seemed that half of the websites and services on the internet would not accept it. So there's the string length, how long a TLD can be. That's a lot better now than it was before, but there are still problems with that. But it's especially the different character sets. And it's not about web browsers. Yes, web browsers matter. Who here still uses email, talking about old technology? Like, I still use email because my work makes me. Email needs to work in other scripts. Right? If you want people to use the internet in their own language, then they need to be able to not only write the email, but also the email address in their own script. FTP, other services, all the applications and all the services we use on the internet at some point need to be agnostic to the script being used. And we have quite a lot of work going forward ahead of us to actually work on that. And ICANN's very active with that. But there's also a lot of people in this region who are very active on universal acceptance. Because this and many places in the global south are the places that have these other languages and these other scripts. So it's important to them. And remember, language is important. not just as an engineer, but as human beings, as societies. Languages are what binds cultures together. So, you know, for those that are working in government and other areas where you worry about culture, the use of your local language, your local dialects, and your local scripts is an important thing. You know, there are a lot of places in the world where they're worrying about the loss of local languages. And some look at things like the internet as part of the issue that is pushing that loss of language, because on the internet, everything still seems to be mostly in English. So this is a big issue for us and will be going forward. Challenges. Ooh, that's a hard word. There are no challenges, there are just opportunities. At least that's always my approach to it. Every time I see a challenge, I look for the opportunity. But there are many. Security. Anybody here thinks that they are completely safe when they are on the internet? I see no hands. That's probably good. If you've read the news at any point in the last 5 minutes, you will have read something, and if you're reading the news while I'm talking, come talk to me afterwards. You know, online security, and this isn't just about domain names, this is about the users using the internet for their day-to-day work, is a real problem. The internet reflects society. And in case you hadn't noticed, there are a lot of bad people in society. And they like to take your money or your data, and they like to victimize people. So we have security issues. And as we bring new people online, we're going to need to educate them about the risks of using the internet. It's not all good. Right? The internet is a great force for good. It really is. And I wouldn't work at ICANN if I didn't believe that with all my heart, that it's a really good thing that really helps society. But we have security issues. We have bad people using the internet. Emerging technologies. Every 5 minutes, there seems to be a new buzzword, a new technology that is going to change the world for everybody for the better. And somebody will be reaching out to you saying, here's this new thing, and you should all be on board because you're going to miss the boat. It's always been thus. You know, it was DNS security and cyber security. We went through a phase where it was cyber everything. They would put the word cyber in front of any issue that was just an issue that we had everywhere else in the world. We even have cyber trucks these days. It's like everything is cyber. But most of these technologies, as they arise, there's a lot of hype. There is a lot of conjecture. There are people selling these technologies who, this may be shocking to you, I know, but they are doing it purely for the money. So that they may not always be 100% truthful with you about what these technologies are. So specifically within ICANN, in the group that I run, where we do research, we spend a lot of time looking at emerging technologies. One of the latest things is, of course, blockchains. Blockchains are great, they have their purpose. And now we have things called blockchain naming systems. So instead of a DNS name, you can have a blockchain name. Some of them are really cool. Some of the technology is really fascinating and it's really cool. The issue with most of these is they are very new and they may have great technology, but they don't yet have the other part that ICANN was set up to do. They don't yet have the policies in place. So they don't know how to deal with the bad guys. They don't yet know how to deal with intellectual property. You know, all of the things that the industry has spent the last, well, more than 25 years, because many of these were issues prior to ICANN, trying to figure out, have still not been figured out in some of these emerging technologies. They also have scaling issues. I had breakfast with some folks doing one of these namespaces, and I asked them, it's like, you know, how are you going to scale? And they said, well, we can scale. We've got tens of thousands of customers. And I said, well, how are you going to scale to 5 billion? And they scratched their heads. Now, some of them may well do it. When you start using things like blockchain and things that have a high computational cost, that generally doesn't scale to global size because it's a massive power consumption and a massive computational cost. The good thing about the DNS, and one of the things that made it successful, was its simplicity. It's based on UDP, single packet out, single packet back. As soon as you go to TCP and you have to start doing multiple packets back and forth, the computation cost goes up, so scaling becomes a problem. This is not a new problem. This is not a problem specific to some of the latest technologies. We at ICANN, and even before ICANN, have been having these discussions with people for decades. So if you want something to scale at the level that the internet scales, it has to have a certain level of simplicity, and it has to have low overhead costs on computation and power. There are many more emerging technologies, and I'm sure that next week there will be a new buzzword and somebody will come and sell you something. All of these emerging technologies are fantastic opportunities, and they all come with scales. The other one that you will have heard lately, I don't know, has anybody heard of this thing called AI? Like, I've heard it's really good. So artificial intelligence, a specific form of artificial intelligence is machine learning. And there's a lot of new machine learning stuff out there, and it's really, really cool. So machine learning and the DNS. So one of the questions I get a lot is, how is, well, people say AI, I say machine learning. How is it going to affect the DNS? And I sat and I thought long and hard about this. And then I asked ChatGPT, because it was much easier. And it was pretty good. It was pretty accurate. I was like, oh, this machine learning stuff's pretty cool. So if you ask ChatGPT how machine learning will affect the DNS, you won't see many surprises. The bad guys are going to use it to make better algorithms and better fish. The good guys are going to use that to make better security protocols and ways of identifying fish. We are probably going to use machine learning algorithms to figure out which are the best names to buy and sell. Right? If you're in the business of buying and selling domain names, then machine learning is, a good way of actually figuring out which strings. The bad guys will use exactly the same thing to figure out which names they can use for scams. We might use machine learning to figure out how to better use caching algorithms. In the DNS, a lot of what we do is remembering names, caching names. Can we build better caching algorithms using machine learning? Now, I don't know, but ChatGPT tells me that's a possibility. So I'm going to trust the computer here. So, just because it's something that you read in the newspaper every day doesn't mean it's not a real thing, and it does not have a lot of opportunities. Machine learning has a lot of opportunities. We use it in our research, especially around looking at ways that you can identify and combat DNS abuse, which we will talk about on later panels. And we're using machine learning there. The problem with machine learning is, of course, it's expensive. Anybody that's tried buying GPUs lately knows how expensive they are, and we know that the big guys have bought them all. I mean, they're spending like billions of dollars on buying GPU units, so it's hard to find. But it's interesting. So emerging technologies, some of it is hype, some of it is fantastic, and if you want to know a lot more about it, go ask ChatGPT or one of the other machine learning. It's very good for writing hip-hop songs about the DNS. We've got one of those. I'm not going to sing it because I can't sing. And it's really good for answering really esoteric questions like, what will machine learning mean for the DNS? So it's actually pretty cool. And the last one is, of course, this issue about getting people online and whether or not we can make the internet work in their own scripts. This is a pretty big one for ICANN because it's actually one of the few things that's actually about identifiers. Right? We focus on identifiers. We don't focus on anything remotely sexy on the internet. No content, a lot of the really cool technologies, we don't focus on that, but we do focus on identifiers. So, can we solve this problem? I'm not sure. I will ask ChatGPT after this. Maybe it knows the answer. So with that, I think I'm at my time. Welcome everybody to this forum. Please do the most important thing of every conference, and that's not listen to people like me. It's go out for the coffees, shake hands, meet people in the industry, say hello to everybody, and have a good time. And thank you very much, everybody local and everybody who came to Hong Kong, and thank you very much to our local hosts for providing this great forum for us. Thank you.
Thank you, Mr. John Crain, for your very insightful keynote speech.